for this lab, here we're going to start off with the Mux 2-to-1. And as you can see, we have three inputs, A and B, and then a selector, and then output of Y. In here, we assign this output of Y to this expression, where it's A and the selector, or the selector with a not in front of it, and B. And so the test bench for this would look like this, where we map these three regulators, A, B, C, to the 2-to-1 mux. See, dot A map to A, B map to B, the selector map to C, and then the output of Y map to the Y of X. And then here for the Mux 4-to-1, now we have we have 7 inputs. Right, yeah. Oops. We have 7 inputs, A, B, C, and D, and then the last 3 are selectors with an output of M. And so here we map, in order to get the 4-to-1 mux, we have to map it to the 2-to-1 mux. So here we're mapping all of these inputs into the inputs from the 2-to-1 mux, and then we're mapping them to the wires that are right here, W0 and W1. And so here in this dot sign, we're comparing them. And so the test bench for this looks like, here we have 4 regulators. So we have F3, F2, F1, and F0. And then we have 3 selectors right here. And then 1 wire of Y, which we then map to the 4-to-1 mux, and then this is just displaying for the timing diagram. Now onto the 8-to-1 mux. Now here we have 8 inputs, and then we also have 8 selectors. So then we map those to not only the 4-to-1 mux, but then we map them to the 2-to-1 mux over here at the end. So this is what the test bench for that looks like. We have, again, 8 regulators, and then over here we have 6 selectors, which we're mapping to the Mux 4-to-1. So we have all this right here. And then again, this is mainly for the timing diagram, for the display of the timing diagram. And that timing diagram will look like this. So, yeah, let me extend it more. So this is what the timing diagram will look like. And the schematic for this mux would look like this. So let me open all these up. Let me zoom out. So then you have all this, and then inside these multiplexers, you have a NOT gate at the start, and then two AND gates where only one of them, where the NOT gate only leads to one of the AND gates, and then both of these AND gates lead to an OR gate. So, yeah, that's the end of lab.